So today we discuss about synapse. In last lecture we talk about the neuron, structure of neuron. Now we further go about the what is synapse. Basically synapse is a structure which pass the informations from one neuron to another neuron. You can see here I draw the two neurons, first neuron and second neuron. So basically a scientist or a neurologist, they in a very early days in 19th century, its name is a Y. Kegel. They find out that neuron is not a continuous structure throughout the body. Even if they are not continue, means they are discontinue, means they are interrupted. So even if they are connected with other, they communicated with each other. So those structure which communicate the two neurons from one neuron to two neurons, this structure it's called as a synapse. Or we can say a synapse. Here you can see this is the first neuron, here the second neuron. So between first and second there is a some space. This space or this structure it's called as a synapse. Synapse is only we can say it's a synapse when they allow the pass information from one neuron to another neuron. Okay, in a suppose in a many bundle of fibers there is two neurons are closing to each other, but they are not permits the information passing the information from one to another. So this is not synapse. Even there is a gap in some book, there is given there is a gap between two neurons, but it is not a true synapse. Synapse is only when they are permits the information from one neuron to another neuron. Suppose this is the first and second. So this part, this is a very microscopic space, microscopic gap between two neurons. So this is called as a synapse. But in many there is a nerve fiber, there is a multiple neuron or axons, but they are not passing the information from one another. So this is not synapse. So what Y. Kegel noticed that a neuron is a not continuous structures. There is a gap between a two neuron. Even there is a gap, they are communicated with each other by some molecule, some chemicals or whatever. So this structure which between two neurons which are responsible for passing the information from one neuron to another neuron, it's called as a synapse. So a synapse is a basically Greek word. You know, we in a medical field majority word derived from Greek and Latin and some from Sanskrit and another language. But synapse means conjunction or means together. So they meaning means they synapse is responsible for making a two neuron or more neurons together, the conjunction of neurons. So this is the basically synapse, very basic informations. So now in this is the, there is a part of neuron, this is a dendrite, cell body means soma, long axon, then there is a axon terminal, there is a dilated part, it's called as a axon terminal or terminal buttons, and here the second neuron starts same. So this first neuron which informations they transmit the information toward the second neuron, means toward the synapse. This is called as a presynaptic neuron. Presynaptic neuron. A gap between two neurons, this microscopic gap, this is called as a synapse or synaptic cleft. Synaptic cleft means there is a space, there is some hollow space, there is a space between two neurons. They are not touching each other, there is some space between two neurons. This space is called as a synaptic cleft. What is a presynaptic neuron? A neuron which transmit the information toward the synaptic cleft. This is a presynaptic neuron. And this second one is called as a postsynaptic neuron. Why it's called as a postsynaptic neuron? this is a post synaptic neuron. So the neuron which they transmit the informations, or which transmit the action potential away from the synaptic cleft or away from the synapse, this is called as a post synaptic neuron. So this is very simple. This is a synapse. Before the synapse, this is a pre-synaptic neuron. After the synapse, it's called as a post-synaptic neuron. And this is a synaptic cleft. It's a very microscopic gap between two neurons. Approximately, it's a 2 to 300 angstrom space. So this is the very basic information about the synapse. Now we suppose this synapse, these junctions are not between the two neurons, they are also neuron to the effector organ. Suppose this is the second neuron, and they make a synapse with the effector organ. Either it is a skeletal muscles, either some glands. So if they make a synapse between the non-neuronal tissue, this is the neuronal tissue, neuron and neuron, between neuron, this is called as a synapse. This is also synapse, but nowadays or before previous day, this is called as a junction. It's a junctions. Synapse is a gap between two neuron, and junction is a gap between a neuron and non-neuronal organ or a non-neuronal tissue. So this is called as a junction. There is example myoneural junction. Myoneural junction. A junction between the neuron and skeletal muscles. This is called as a myoneural junction. But nowadays this is also called as a synapse. We can say my junctions and synapse are similarly both structure, because in passing informations are in the same way. So we can say it's a synapse as well as junction. So what is the purpose of synapse? Synapse are responsible, or what is a synaptic function? What is purpose or synaptic neuronal functions? So informations carrying from one neuron to another neuron. From one neuron to another neuron. This informations, first is it can be blocked at the synaptic level. So suppose this presynaptic neurons and postsynaptic neuron both are firing, both are passing the action potential, some informations. But after some times this informations should be blocked. So what they do, the presynaptic neuron secretes a neurotransmitter which responsible for blocking, means they block the informations. Now they inhibit the postsynaptic neuron. So this is the first purpose. Second is, these informations maybe they are modified. Or third is, this information may be increased, or we can excitatory function. So synaptic function is they either modify the informations at the synaptic level, either they block the informations which coming from the presynaptic neuron, either they excitate the postsynaptic neurons. So basically synapses are responsible for modify the informations, either they change, either they increase or decrease. So this is called as a synaptic neuronal function. So what is exact this, how it's happen, we will see mechanisms of synaptic transmission. So let's start. First we talk about the structure of synapse or classifications of synapse. Synapses are basically divided in two ways. Synapses are basically divided into two ways. A physiological way or a morphological, or as per morphological, or as per we can say anatomical way. But this is a morphological and physiological. Physiological synapse, there are two types. We divide the synapse as per physiology. There are two types. by its function. First is called as a chemical synapse, or second is called as a electrical synapse. So what is different between chemical synapse and electrical synapse? We know previous diagram is chemical synapse. Chemical synapse are those synapses which having a basically a true potential space or true potential gap between two neurons. Suppose this is the axon terminal. I draw here. This is the axon terminal, and here the post. Okay. This is a presynaptic neuron. Presynaptic neuron. This is a postsynaptic neuron. Between pre and post there is a space. This is called as synaptic gap. And informations travel or information sharing via some secreting a chemical. So this is called as a chemical synapse. They use the chemical to pass the information. So basically in chemical synapse, action potential or electrical current reach up to the terminal button, or this is called as a terminal knob. Terminal button, terminal knob, axonal terminals, whatever, many words for this terminal part. Now we use as a terminal button or synaptic knob, whatever, many word for this. So action potential or electrical current reaching up to the terminal knob, and this terminal knob having some vesicles or some chemical substance which secretes here in synaptic cleft, and this chemical bind with the postsynaptic neuron, and now they transmit the information from in postsynaptic neuron. So they have a basically true space between two neurons. This space or this gap, size of this gap is 200 to 300 angstrom. So there is a microscopic gap. It's not a naked, we cannot see naked, but there is a space. They are not directly connected. So this type of neuron is called as a chemical synapse. This type of synapse is called as a chemical synapse, which communicate the two neuron with help of some chemical substance. Mainly we call it as a neurotransmitter. And what about the chemical synapse? A chemical synapse, if there is a postsynaptic neuron and presynaptic neuron, I draw here. Okay, this is a presynaptic neuron, postsynaptic neuron. Between the pre and post there is a tubular connection. So there is not true, they are not truly gapped between this. There is no space, but they are connected with plasma of presynaptic neuron and plasma of postsynaptic neuron are there connected with a microscopic or tubule-like structure, or there is a connection between two neuron. So this type of junction, it's called as a gap junction or electrical synapse. This type of connection is called as a connections. There is a thousands of connection between two neurons. So what is the advantage of this type of connections or this type of connections? They are responsible for fast conduction, because here what happened, electrical current reach to the terminals and they convert into the chemical energy, and again they convert into electrical energy. So they shows some delay. They shows some synaptic delay. So this type of delay are not shown here. Electrical informations or electrical whatever anions or cations, they are directly connected with next neuron. So this type of gap junctions, they are responsible, they are not shows the synaptic delay. So they are responsible, what is a properties or what is the advantage? They are responsible for fast conduction and they avoid the synaptic delay. And this type of connections, they are not a unilateral or a one-way conductions. They shows the bi-way conduction as per chemico-electrical gradient. Suppose here the sodium is more, so this sodium travel from here to here. But sometimes sodium are here more, concentration of sodium is more. So this sodium going from here to here. So this shows the bi-way conduction. But here there is a one-way conduction. Here the one-way conduction. It's like a one-way road. It's a bi-way. And second is this type of connections, they shows the very synchronized actions. Synchronized means they responsible for very synchronized action in different part of area. So due to fast conductions, they shows the synchronized actions, means same type of actions in larger part. So this type of gap junctions are mainly seen in our cardiac tissue, myocardium, in our conducting systems of heart. They having a gap junctions between two myocardium cell. So they shows the cardiac contractibility very synchronized way. It's not happen in right side of heart are contract first and left side are contract later. They shows the very synchronized activity. But this type of synapse also present in brain, but majority synapse in our nervous system is a chemical type. But in cerebral cortex means majority interneurons, they shows the gap junctions or electrical junction. Okay. Now talk about the morphological classifications. This is a very easy. Morphological classification means they are depends on the connections between two neurons. A part which involve first type of is called as a exodendric or dendrites. Dendric. Exodendric means a post-synaptic neurons axons make a connections or make a synapse with the dendrites of second neuron. This is a neuron axon. So this is a axon terminal. This is a dendrites and soma and again axon. So this type of synapse is called as a here. This types of synapse is a called as a exodendric. Means they make a synapse between the next neuron with the dendrites. Okay. First presynaptic neuron. Suppose this is a axon. They make a synapse with the post-synaptic neuron, but dendrites portions. There is a dendrite, soma, and axon. So they make a synapse with the next neuron with the dendrites. Second is called as a exosomatic. What is exosomatic? Exosomatic means a presynaptic neuron. Here the presynaptic neuron, they make a connection between the directly with the soma. Here the soma. So this is a soma, this is a dendrites, but they make a connection within a axon between the body of neuron. So this is called as a exosomatic synapse. And next is a axonic. Means suppose this is a presynaptic neuron and here the postsynaptic neuron. So they make a connection with the axons of next neuron. This is a presynaptic neuron, postsynaptic neuron, and here the synapse. They make a connection between the axon to next axon. But this type of synapse are seen very less. Majority 90% synapse are exodendric and chemical synapse. Okay, exodendric and chemical means they are a chemical synapse, exodendric. They make a connection, a chemical connection in a dendrite of next neuron. Only 5 to 10%, 5 to 8% are exosomatic and 1 to 2% is a exoexonic. So this is about the classifications of neurosynapse. In next video or next lecture we talk about the mechanisms of synaptic transmission.